Draw a direction field for population growth. So our equation for population growth is p prime equals k times p. We're going to use k equals 10 in this example, and we have p of t is greater than 0. All right, so we're going to say p of t is also in grams. I'm hoping there's not that much bacteria in cartons of milk. So then if it's in grams and it's not very much, then I have p of t. Let me fix that t. And I'll have time. And I'm going to use 0.1 grams up here. Right, and we'll go down further and further. So the first thing, right, we don't want p is less than 0, so we're going to ignore this. You know, p less than 0, that's negative population. So it's unrealistic. All right, so let's go ahead and get started. So if I use 0.1 and I plug it into the differential equation, let me just put the k in explicitly, so it's 10p. Then 10 times 0.1, well, that's going to be a slope of 1. So I think I can draw that. It's a pretty good slope 1 line. All right, but if I go down to 0.05 grams, then it's going to be a slope of 1/2, I'm pretty sure. Something like that. So I'm just going to try and fill these in best I can. So, I don't know, that could be a half slope. And then the slope is going to get closer and closer to 0 as we get closer and closer. Let me try and make that even closer to horizontal. Right in between here, it's going to be something like that. It's hard to draw. But there we go. So also, if we draw some direction field lines for this, it does make sense. If we start out with a positive population, we expect the population to grow, and that seems to be indicated by the slope field lines as well, the direction field. Right, they'll go upwards. Something like that. Again, within reason, so these can't reproduce to infinity. This graph seems to indicate that they'll just keep growing and growing, but eventually they will run out of food or run out of space, such as in a gallon of milk. There's only so much milk, there's only so much volume in the gallon, there's only so much milk in the gallon.